right, this is a warm up today. So if you are doing this at home, you should pause the video and give it a shot. So as we're solving this inequality, it's going to be a lot like solving a regular equation, except for we have the inequality there. So we're going to need to distribute this 4 to the parts inside the parentheses. So on the left, we have 5x plus 8 still. That doesn't change. Is greater than 7x. And I'm going to make a 7 like that. I don't usually draw my 7s like that, but when I'm doing greater than and less than symbols, it's helpful. Plus 4 times x, that's 4x. And 4 times negative 4, that's negative 16. So there's my first step. Now on the right-hand side there, I can combine my x terms right there. So on the left, I still have 5x plus 8 is greater than 7x plus 4x, that's 11x, minus 16. I can move my x terms to either side of the equation. It doesn't really make any difference at all. I will subtract 5x so that I have 8 is greater than 6x minus 16. Now I can add 16 to get my x terms by them, or my x term by itself. So I have 24 is greater than 6x. The last step here needed to isolate my x is to divide by 6. When I divide by 6 there, I have on the left-hand side, I have 4, because 24 divided by 6 is 4, is greater than x. So that is my solution. To graph that, I make a number line. I put 4 right in the middle. Because this is a greater than symbol without an equal to, it's an open circle. Here, I'll do a different color there. Why not? With open circle. And that means that it's not part of the solution. And then when my x term is on the right-hand side of the inequality, my arrow has to face the opposite direction as that. I can also just plug in a test value. So my test value is 0. So 4 is greater than 0. That is true. So I put my 0 on the number line, and I shade toward my test value, 0. So I have to shade this direction. Yeah. I got you. I'll do it. I'll do it right here. So it's x is less than 4. Yeah, if you do that, then whenever your variable is on the left-hand side of your inequality, your arrow here will face the same direction as the inequality. Yep, that works, Jojo. So that is the graphing of that one. And the question is 8 a possible solution to the inequality? So here I'm going to put 8 is like right there. And if we plug 8 in, 4 is greater than 8. So I plugged 8. I took this, that was the one that I was using, and I plugged in 8, which this is asking about. This is not true because 4 is not greater than 8. So the answer is no. And we can see graphically, here's 8, and it is not included in the shading, so it is not part of the solution. Questions on that? All right. All right, since we're talking about two variable inequalities, we're thinking about an XY coordinate plane. And if you think about a line like a y equals mx plus b line, it's some straight line. The b is our y-intercept, and the m is our slope here that we can calculate. But now we're going to be looking at an inequality. So this is an equation because there's an equal sign. Now we're going to be looking at an inequality like that with two variables, x and y. Okay? So just like when we think about the one variable, when we think about one variable inequalities, if we have a greater than or less than symbol, we have open circle. But with two, so this is one variable. But with two variable, when we have a greater than or less than, we have a dotted line. In the case of one variable inequalities, the open circle means that that point is not part of the solution. In two variable inequalities, when we have a dotted line, it means all the points on that line are not part of the solution. It's a solution set. So in contrast to that, when we have a greater than and equal to or a less than and equal to in one variable inequalities, we have a closed circle. And that means that that point, wherever that closed circle, is part of the solution, or yeah, it's part of the solution set. In two variable inequalities, when we have a greater than and equal to or less than and equal to, we have a solid line. And that means those points on the line are part of the solution set. So over here, these are not part of solution set. And over here, these are part of solution set. Yeah. Oh, so in one great question. A one variable inequality is like x is greater than 4. A two variable inequality is like y is less than or equal to 3x plus 5. So one variable, two variables. Yep. Here, let me erase the, whoops, that was too big of an erase. Let me erase that because it looks like it's related to these. So, all right. Questions on that? All right. Now, in two variable inequalities, as long as y is on the left, this must be the case for this thing I'm about to tell you. All right? As long as y is on the left, like y, so this is going to be a couple of examples. Y is greater than or equal to negative 2x plus 6, or y is less than 1/2 x minus 7. So those are examples where y is on the left, all right? So non-examples, so this is a non-example. So 4x plus 7 is less than y. So this is a non-example, all right? So when y is on the left, when that is the case, then this or that, I should say and, so a less than and a less than and equal to, shade below. If it's a greater than, I guess that's an or, not an and, or greater than and equal to, shade above. And you could switch this one to an example by doing this, flipping it around. Y is greater than, so I switch the sign, 4x plus 7, and that's perfectly allowed. Now it's an example. Questions about that? Let's take a quick break because I'm going to need you guys tuned in fully when we come back. So take a quick break. All right, so keeping on with these notes, we're going to do a couple examples, all right? So here's our first example. And it's going to be y is greater than negative 1/2. Y is greater than negative 1/2 x plus 3, right? And so we're going to need a grid. So I'm going to draw a quick grid here. And I hear my cat getting into something over there. Just a minute. Okay, so there's my grid. I'm going to make this a 1, 2, 3, 4. We'll go by twos. All right, so the first thing is to notice that this is a greater than symbol with y on the left. So we can follow these rules right here. And there's no equal. So gonna be it's gonna be dotted. It's gonna be a dotted line because it's just a greater than. So at 0, 3, there's my y-intercept. So 0, 3, here's my y-intercept. And then my slope is going to be negative 1/2. So that means that I go down 1 and to the right 2. Down 1 and to the right 2. Or up 1 and to the left 2. So that means that I'm going to have points here, 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 and then it can continue on like that. Now, I said that it was a dotted line, so I'm going to connect those points with a dotted line. My kids are ringing the doorbell over and over again. That's good times. So there's my dotted line because it's just a greater than, not greater than and equal to. And because my y value is on the left, and this is a greater than symbol, then I shade above. All right, so that means that I'm going to shade above, which is up here. So all of this and it continues on forever like that, is part of the solution set. Every point in that shading is part of the solution set. So we can try a test point. Whoops. Try a test point here. And we can try any test point we want. We can try a test point in the shaded area, not in the shaded area, whatever we want. I'll use a test point in the shaded area. And I often pick easy points where either x is 0 or y is 0. So our test point is going to be 0, 4 here. So we're going to plug in 0 for x and 4 for y. So 4 plugged in for y right there. 4 is greater than -1/2 times 0, that's our x value, plus 3. This right here becomes 0 because any number times 0 is 0. So 4 is greater than 3. And that's true. 4 is greater than 3. So 0, 4 is in the solution area right here. Any point that we chose over here would come out to be a true inequality. Any point that we chose over here would come out to be a false inequality. And any point on the dotted line would also come out to be false. And I'll show an example like that as well at some point. Let me do it right now. So I'm going to copy all this and bring it over here. And so now I'm going to choose a different point. I'm going to choose, how about 0, 0? That's a nice, easy one to plug in. So, oh, I guess I should have also brought over this. Okay. So plugging in 0 for x and y, we have 0 is greater than -1/2 times 0 plus 3. On the left, 0 is greater than. This becomes 0, so on the right, we just have 3. And so that is 0 is not greater than 3, so that's false. So the point 0, 0 is not part of the solution set. And then I'll do one on the dotted line as well. One last test point just to show you kind of what I'm talking about here. So I'm going to choose, how about this point right here, 2, 2. So plug in 2 for y. 2 is greater than -1/2 times 2 plus 3. Okay, so this -1/2 times 2 is -1. So we have 2 is greater than -1 plus 3. -1 plus 3 is 2, so 2 is greater than 2, and that is false. If there were an equal sign here, it would be true, but since there's no equal sign, it's false. And for any point on the line, and this is always true, you'll come out with a situation like this. Okay, questions? All right. Whoops. So the next example I'm going to use here, example 2, is going to be a little more complicated. You'll have to do this sometimes. So notice that in this case, it's not solved for y. So you'll need to solve for y. We need to first convert to slope-intercept form. And slope-intercept is y equals mx plus b. And be careful here, equals, it's not really equals, because it's an inequality, but same idea. So in order to do that, we're going to add 2x here, and we'll get y is less than or equal to 2x minus 1. Questions on that before I move on? All right, so there's my grid, and my y-intercept is -1. So I'll plot that first. 0, -1, I should say. 0, -1 right there. And then my slope is going to be the 2, and that's going to be up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, or down 2 to the left 1. Either one of those works. And then, so I can have a point here, and there, and down there. And because this is a less than or equal to, it's going to be a solid line. So I connect that with a solid line straight through those points like that. Now, because we have our y value or our y variable here on the left of our inequality, we can just look at the inequality and say, all right, it's less than or equal to, so that means I shade below. Less than means shade below. So I can grab my highlighter here and shade below. And sometimes students have a hard time determining which side is below and which side is above. And here's the way I think about it. If rain were falling down from the sky and hit this line, it would flow this way. That means that side is above. If rain were falling down here, it would never hit the line. That means that's below. So above will hit the line and flow one way. Below never hits the line. Questions on example 2? Notice that example 2 was a little harder than example 1. We have one more example, which means we need to get a little bit harder, right? Each time we get a little bit harder. All right, whoops, I keep doing that. All right, here is example 3. And this time we're going to graph a system of not equations, a system of inequalities, because they're not equal signs. They're less than or equal to, greater than or equal to. So they're inequalities. So we have 2 inequalities. The first one is y is less than or equal to, here I want to use a different color here. Y is less than or equal to -1/3 x plus 4. And the other inequality that we're going to do is -6x plus 2y is greater than 4. Notice that on that second one, we're going to need to do some stuff to it. All right. We're going to need to do some alterations because it's not in y equals mx plus b form. So what I need to do is I need to add 6x to both sides, and I'll get 2y is greater than, whoops, not or equal to, greater than 6x plus 4. And y is still not by itself. We need to divide by 2. So I divide each term by 2, and I get y is greater than 3x, because 6x divided by 2 is 3x, plus 2. So there is my second inequality. So I'm going to use this one and this one because I just took that original inequality and converted it into a different form that I can graph more easily. Need to make my grid. It's not perfectly straight. That's all right. There's my grid. And you may ask, why didn't I put my x-axis here? Why didn't I put it up here? Oh, I did that because I saw that my y-intercept here was a 4. So I'm going to need to, put a point up there. That's why I did that. All right, so let's graph the green line first. So my y-intercept is the point 0, 4. So I'm going to have a point right here. And then my slope is negative 1/3. So I'm going to go down 1 and to the right 3, or up 1 and to the left 3, up 1 and to the left 3. And so my points will be right here and here, and then my y-intercept and there. And because this is less than or equal to, the equal to tells me that I need to make it a solid line. So I'm going to, whoops, come this way. And my y is on the left of my inequality. So I can just look at my inequality and say, all right, less than or equal to, less than means shade below. So I can shade below that line down here. Trying to be careful there so that it looks correct. Shading all this in. All these points that I'm shading in are part of the solution set. And something that you may not have thought about, and that's okay, is that even a point like right here, where I don't know exactly what the x and the y values are because it's not a whole number, that is part of the solution set. Here's part of the solution set. There is, right on the line, that's part of the solution set. Right here, that's part of the solution set. Any point over here is part of the solution set for that one inequality. Over here, none of these points are. All right, now we're going to graph our other inequality unless someone has a question. Slow down here for a second and see if anyone wants to ask a question. We're going to graph the two inequalities on the same graph because any solution to the system has to be a solution to both inequalities. Great question, Jojo. All right, so graphing the orange inequality, I'm going to put how about a yellow point for my y-intercept at 0, 2. So right there. And my slope, let's make my slope this sort of a pink color. So my slope is 3, which means go up 3 and to the right 1. Up 3 and to the right 1. Or down 3 and to the left 1. So I have points here and there and there. And because this is just greater than, not greater than or equal to, it's just greater than, that means it's dotted lines. Whoops, that was supposed to be, those were supposed to be orange points, weren't they? Let me fix that. So dotted lines between those orange points. And because the y value is on the left of my inequality, and my inequality is greater than, I shade above. So I shade up here because rain falls down, hits the line, and goes that way. Over here, this would be below because it would never hit it. So I shade above. So all of this area is part of the solution set for that particular inequality. I haven't yet answered the question where the solution set is for the system, just each individual inequality. But you maybe can look at that graph and say, oh, I see where the solution set has to be for that graph. It's the spot where the two solution sets overlap. In here. All of this area here is the solution set for the inequality. All right? If you don't have a highlighter, when I'm working on paper, I like using highlighters. But if you don't have one, that's okay. You can do this. When shading below the green line, you could use. I'll use black just so you can see it. When shading below the green line, you can put arrows like this. And it's below the green line, so it's everywhere right here. And then for the orange line, it's above the orange line, so it's everywhere right here. And what you can see happens is that the places where the lines intersect, this is all part of the solution to the system. Over here, these aren't intersecting with the other lines, so that's not part of the solution. Down here, these don't intersect, so that's not part of the solution. And there aren't any arrows here, so that's not part of the solution. Questions? So all of this area in here is the solution. Yep. And you could do something like this, solution region. That might be helpful. You don't have to, but you could. And I'm going to then copy this over to the next slide because I want to continue working with it. And continue on with this question and say, which of the following is a solution? So first, how about, we'll do it this way. 2, 1, 1, -1, and 3, -4. All right, so we'll make this one yellow, not yellow because we already used yellow, kind of this beige, and a light blue, and a dark blue. All right, so 2, 1, 2, 1 is right here, and that is not part of the solution because it is part of the green region, but it's not part of the orange region. So it is not part of the solution. The 1, -1, 1, -1 is right there. And again, that is part of the green solution. It's not part of the orange solution. So that is also not part of the solution for the system. The last one there, 3, -4. Well, that's going to be down there, also not part of the solution. So no. All right, so can someone name one that will be part of the solution? Any point part of the solution. -3, 2, right there. -3, 2. Yes, it's part of both solution regions, so it is part of the system of equations solution. Systems of inequalities solution. Good job, Jojo. All right, questions? -4, 3 would also be part of the solution. Yep. Okay, we're not going to do the Padlet because of, well, we might. Yeah, I'm going to grab it real quick and give it to you guys. Where did it go? I'm fumbling here, folks. Sorry. All right. Here is the Padlet link. Go to that. Oh, that's not the right link. Ignore that link. I'll give you another one. Here we go. All right. Here it is. Go to that link. And so what you're going to do is you are going to post on there. Which one of those doesn't belong? And there is no correct answer as long as you give an explanation. So notice that it's the same as is on my screen right here. So name the one that doesn't belong and name why. There's more than one answer. Okay. And if you click on the Padlet picture, you can see it up closer. And you can add your own. So when you're ready, you can just click on the little add and it will add an answer.